talk now. We have Mark Helmsetter, Principal Consulting Engineer at MongoDB.
Thanks, guys. Thanks for coming out on Saturday. And today I'm going to talk about MongoDB 3.2 goodness. So first, just kind of a look back at some of the previous releases of MongoDB. How many of you here are using MongoDB today? Okay. And how many of you are brand new to MongoDB? You've never used it before, but you've heard of it. You know how to spell it. Okay, good. Those of you who are brand new might be missing a little bit of context, depending on how much knowledge you have about MongoDB. I'm primarily going to focus on our most recent production-ready release, which is 3.2. It's actually been around for about 7 months now, so it's not brand new. I think normally this talk probably would have been called "What's New in MongoDB 3.2." That kind of rhymes a lot better than MongoDB goodness. So I'm going to talk about some of the features that were introduced. As you can see by the list, I don't think we manipulated this too much, but it's definitely our biggest release to date. 3.0, which came out, I guess, about 2 years ago, maybe, was a really big release. Introduced the wire-tagged storage engine, which gave us document-level concurrency and compression. There were a number of other features in that release. The features in the 3.2 release, we added document validation, fast failover, lots of improvements for scalability and multi-data center deployments, improvements to our aggregation framework, the addition of 2 new storage engines, an encrypted storage engine and an in-memory storage engine, a new BI connector, the $lookup operator, a query tool called MongoDB Compass, application performance monitoring tool integration, a visualization tool for the profiler, automatic index builds, partial indexes, and file system backups as part of OpsManager. So I'm going to talk about that list in the 28 minutes that I have left. So first, the first major category of features in 3.2 we're going to call data governance and intelligence, or business intelligence. And we can kind of break that down into 3 main categories. So we added a new dynamic lookup feature, which I'll talk about. We added schema validation and the BI connector. So there's a new operator in 3.2 called $lookup. So those of you who know MongoDB well, or know the tenets of document-based NoSQL databases like MongoDB, you're probably aware that typically in a system like MongoDB, you usually denormalize your data so that you're not going to do joins like you would do in a SQL database, right? So usually we have all of the fields that we need for a particular use case in one document. The MongoDB itself historically has not had direct support for joins. And so in 3.2, we added this $lookup operator to the aggregation framework that allows you to do simple left-outer join operations. So documents in MongoDB are organized into collections. So you can imagine that you have one collection called orders, and you have another collection called inventory. You could easily join together those 2 tables. Another simple example might be probably something that would be better suited for $lookup would be if you had lookup data, right? So you might have an ID. For whatever reason, you don't want to store the state or country or all of the information about an airline, depending on what type of application you have. You want to store that in a separate lookup table rather than embedding that data directly into the document. So $lookup will allow you to easily do those kinds of joins. The way it works is, this is the syntax that you would use in the Mongo shell. So you would say db.collectionname.aggregate, and here you would optionally have your other, like your actual query criteria, which would be a match condition in the aggregation framework. And then you can add the $lookup operator there. You specify the from, which is the right collection that you're looking up from. The local field and the foreign field are the two fields that you're going to do inequality match. So you might be doing inequality match on something like an ID, or equality match on something like a name, or some other kind of unique key that you want to join up. And then finally, you specify the as, which is an array field that will be inserted into the document. So what you would end up with is the left collection, the documents from the left collection, joined with an additional field that is the as field that will contain your data from the lookup. Okay, so one of the other cool features of MongoDB is that we don't enforce any schema, right? So you can take whatever documents you want and store them in MongoDB. All of your documents may have the same schema, which is probably the more common case, or you might have subtle variations of schema among different documents within the same collection. When I teach people about MongoDB and I tell them that, there are usually a handful of people in the room that are scared as hell whenever I tell them that, right? They're like, what do you mean? You're going to let me put anything I want in the database? What about governance? And so it's usually the DBAs that are really scared and uncomfortable with that. And usually, in the past, the answer that I've given them is that it's really your application that is enforcing the schema, right? So your application is controlling what data goes into the database, so the application is what's doing the validation. For those who have really wanted to have that extra level of protection that they're used to having with the database, we added this new feature called document validation. And so you can create a validation expression on a collection. You can specify one field, you can specify multiple fields, and you can compose an expression that basically says whether or not a given document would be valid. An example is probably easier to illustrate. So here we have, if we have an existing collection, we would run the call mod collection modifier operation and specify the validator. And so here's a JSON expression that specifies our validation rules. And in this very simple example, we're validating that the year of birth is no later than 1994, that the document contains a phone number and/or an email address. And when the phone number and email address are present, they are of type string. So you can see how you could compose whatever validation logic you want to enforce using that type of expression language. And then you specify two additional options, which are the validation level and the validation action, which I will describe here. So basically, the validation action, you can say, I just want a warning, or I want to error when the validation passes or fails. And then you can control the level of the validations. You can turn it completely off. You can have a moderate validation level or a strict validation level. The default is validation action is error, and validation level is strict, which means that any violation of the rules for any insert or update will be rejected. So the updates will be rejected. Whereas in the moderate state, you can still do, in some cases, still do the operations, and the update will still fail, but at least you'll get an error in the log indicating that something happened. So you can see how you might want to phase in the implementation of this, so you have some idea of how it's working, and you can control it that way. All right, the next feature that I'm going to talk about is the MongoDB Connector for BI. So business intelligence tools have become extremely popular in the last few years. People love fancy graphs and charts that these tools produce. And lots of people who are using MongoDB have wanted to have a way that they can use these tools with MongoDB. So before this, you would have to ETL the data out into some other database or or figure out some way to build a custom connector to connect tools like Tableau or Click or whatever BI tool you'd like to use into MongoDB. So now we natively provide this BI connector. And what it does is it kind of sits in the middle between MongoDB and your BI tool, and it translates the SQL. So all these BI tools are basically just stood up SQL. It translates the SQL into MongoDB queries. So typically, with a BI tool, you would have your database on one end, and you would have your analytics tool, and they would connect directly together. So the BI tool from MongoDB basically sits in the middle and translates your document-based SQL, MongoDB, JSON documents into tabular format. Okay? There's a bit of magic in terms of how we actually do that. And we came up with something called DRDL, DRDL, which is Document Relational Definition Language. And setting this up is pretty simple. In the basic case, you can run this tool called MongoDRDL, point it to a MongoDB database, and it will basically look at all of the collections within that database, and it'll generate a default mapping for the fields within that collection by sampling documents from within that collection. Once you have the DRDL file, which defines your schema, then you run this MongoDB BI schema tool to import that, and you're basically associating a particular schema mapping with a particular user that's going to connect via the tool. You see this business over here on the left, which I didn't talk about yet. Postgres MongoDB specific foreign data wrapper. A lot of people see Postgres and they think that we're actually exporting data into a Postgres database. It just so happens that we're just using these Postgres APIs, this foreign data wrapper API that Postgres provides, so that we can simulate your tool when it connects to the MongoDB BI connector, thinks that it's talking to a Postgres database, basically. So that's the dialect of SQL that the connector is talking. Here's a quick example of what the DRDL looks like. It's a YAML format, plain text file, defines the mapping of a table name to a collection name, and basically the columns, attributes, and data types of everything that's contained within there. After you use the DRDL tool to generate that, you can manipulate this to change the names if you like. If the sampling gets the data types wrong, you can adjust that. And you can also do more complex things like actually build aggregation queries. So instead of just reading from one collection, you could use $lookup to actually join two collections together, and the BI connector can do that. I guess the other thing that I should probably mention is that most of the queries that these BI tools are doing are like aggregation type queries, right? So you're doing analytics type queries, right? So you're doing group bys and counts and averages and mins, max, whatever. All of that gets translated in SQL generally into aggregation framework queries. So it gets pushed down to your MongoDB database. And it's actually the database itself that's doing the hard work of aggregating. And the connector is just sitting in the middle, basically translating. Okay. This is something else I decided to throw in here is that we recently, about a month ago, released a connector for Spark. I didn't get to see any of the talks today, but I noticed that there were several topics about Spark here. Spark is kind of the hottest thing going on right now, and we just like I said, a month ago released this connector. And so if you're building Spark Analytics applications or thinking about building Spark Analytics applications and you want to use MongoDB, you should check out this connector. It supports the full set of Spark APIs, whether you're using Scala, Java, Python, R APIs are all supported. And if you want to check it out, there's the link there, MongoDB.com, products, Spark Connector. storage engines. So, I mentioned WireTiger came out in MongoDB 3.0. Now in MongoDB 3.2, it is the default storage engine. I usually recommend, if you're building a new application from scratch, starting with WireTiger is going to give you probably the best performance. Compression is a huge win because it's going to greatly reduce the amount of storage that you require, and it will give you really good concurrency and performance. MMAP v1 is the storage engine that's been around since the beginning of time in MongoDB world, or as far as MongoDB is concerned. It performs well with various workloads, particularly if you're doing in-place updates. MMAP v1 does pretty well with that. It has slightly more granular blocking scheme that it uses, and it also does not have compression capabilities. The two new storage engines that were added in 3.2 are the in-memory storage engine. So if you have a use case where you care about every millisecond of latency, if you're in telecommunications, or if you just have some type of application where you have a really strict SLA on what your query response time is, the in-memory storage engine might be something that you can look at. The cool thing about the way the in-memory storage engine works is that you can use MongoDB's replication, which is our solution for high availability, and you can actually have different storage engines within the same replica set. Right? So I can have a replica set that has two members that are in memory and one member that is WireTiger storage engine, because, well, if you're using in memory and somebody pulls the plug on the server, you just lost your data, right? So if you want to persist that data, if you actually care about keeping your data, you can just replicate that data to other disk-based nodes. If you lose an in-memory node, when that in-memory node comes back up, it'll just start syncing from one of the other nodes in the cluster that still has the data. If you're working with any type of sensitive data, PHI, PII type data, you might have a requirement to encrypt your data at rest. And now in MongoDB 3.2, we offer an encrypted storage engine. So instead of having to use like an encrypted file system or some other encryption technique, you can accomplish encryption at rest just by simply using the encrypted storage engine. And it's also based on WireTiger. So obviously, within memory, you can accomplish new types of workloads and new sets of requirements with those two new storage engines. Okay, tools, enhanced tooling in 3.2. Application performance monitoring tools. We have modified the drivers in 3.2 so that there is a set of instrumentation that can be turned on. And tools like New Relic can connect via this API and gather performance. So you can see what does the latency of my queries look like, and you can turn that on and off, and then view that through the dashboard of your APM tool. Query profiling. So the query profiler has been around for quite a while, but we've never really had a good tool for actually visualizing the query profile output. And so now in OpsManager, which is our monitoring and management tool suite, you can actually visualize, when you turn the profiler on, you can actually visualize the response times of all queries within your system. And last but not least, I'm going to show a demo of this tool here in a moment. There's a new schema discovery tool called MongoDB Compass. Oh, I'll show that to you now. So this is what Compass looks like. So Compass is a desktop application you would run on your PC. I believe we support Windows, Mac, and Linux for this tool. You can see on the left, I am connected, so I can connect to a specific database. Here I'm connected to, this is actually just my local computer, which happens to be called World. And on my local instance that's running on my laptop here, I have 16 databases and 43 collections. You can see in the left pane here what all of the databases are and what all of the collections are underneath there. Here I have this database called WDTCS, which stands for something that I don't remember what that is, but basically it's a data set that has data about ships and containers and ports. So we're like shipping containers, you know, the big cargo ships. And so what this tool is really good for, again, people get really scared when they talk about the fact that not every document in a collection can have the same schema. So a common question that people ask is, well, if every document can have a different schema, how can I actually see like what my data looks like? And so this was originally designed to be kind of a visualization tool, so you could see, you know, what the distribution of values were, what all the fields were within each of your collections. We accomplished this by sampling data within the collection. So you can see here at the top, I don't know if all of you can read that, but this particular collection, which is the containers collection, has 911,000 documents, and we did a random sampling of 1,000 documents. I can refine that sampling by either typing a query here in this box or by interacting with the UI. So even if you don't know anything about MongoDB query language, you can simply click on fields within here. You can drag on the histogram, and dynamically that populated the query. So this is an inquiry, so I selected 3 different values. So cargo, spices, horses, and uranium. Okay? Didn't know you could ship horses on a ship, but
Not that the army are on the ship. You watch Game of Thrones?
no, sorry.
It's okay.
Another cool feature, so you can also select different values here. So that is an implicit and. So I just selected a particular container ID. So that's populating this query. Oh, I just realized this isn't showing the whole thing here. If I click apply now, well, what's what happens when you do a live demo? So for cargo, horses, uranium, and spices, we now have, instead of 911,000, we have 138,000. You can also notice down here, oh, bummer, I don't have an internet connection, so. Sorry. So my map is not displaying. Let me just turn on my tethering. Hopefully it'll actually pick it up here. Well, anyway, you can imagine that these dots, there's actually a background here on the map, and you can hold down Shift. You can click on points here, or you can hold down Shift. I guess it doesn't work whenever the map can't display. So we use a third-party mapping provider. But anyway, you can basically do a point radius query here, so you can just drag and draw a circle, and that'll zoom in on one of the ships. What I actually discovered from this data set, which is also really cool, is that each container has its own GPS coordinate. So when I zoom in on the ship, I was like, oh, there's like 100,000 documents here. And then whenever I clicked on the ship, then you can actually almost see like an outline of GPS coordinates of the specific ship, which is pretty cool. Okay. So that's Compass. We also give you a couple other features. Some numbers about the number of documents, the number of indexes. You can also see what the actual raw documents themselves, and these documents, if they're hierarchical like this, you can actually drill down into the JSON, which is a nice little feature. Another cool thing that we added just recently in this tool is doing explain plans on your queries. So you can actually see here, this particular query, I don't have an index on the cargo field, so it's doing a collection scan. And you can see that it took 470 milliseconds, whereas if I were to reset and do it on, well, let's see, what indexes do I have? I have an index on location, I have an index on ship name, so if I go down here and select a ship name and apply that, now, oh, that's what here you can see the cluster of all the containers on the ship. If I look at my explain plan here, you can see the index scan took 0 milliseconds, and the actual fetching of the documents took 10 milliseconds. And you can also see the raw JSON. So if you run the explain in the shell, this is what the raw JSON would look like. So you can actually see what that is. And here you can see what indexes I have on this collection. So I have the default index of underscore ID. I have a 2D sphere index on the location, and I have a compound index on ship name and cargo. So that's Compass. Probably going to have to skip this demo here, and I actually don't have a very good live demo because my data does not look as pretty as this nice little scatter graph, so I'll just talk about this. So this is, there are two tools, two monitoring and management tools. Cloud Manager is a cloud-hosted version, or you can run the same tool on-premise, which we call OpsManager. This is the monitoring and management tool, and one of the new features in 3.2 is this visual query profiler. So you can turn on the profiler, which starts gathering all of the data about your specific queries, what the latency of the query is, and other statistics on those individual queries. That data gets captured in a capped collection inside of MongoDB, and Cloud Manager or Ops Manager can sample that data and plot it on a graph. And what we'll see here is the different types of operations. So here we have the namespace, which is your database and collection, what type of operation it was it an update, was it a query, was it some other type of command like a count command, how many of those operations were captured during the profiling, cumulative time in milliseconds, and the average time in milliseconds for the execution times. So this can give you a good indication. As a consultant, I'm usually going in and helping people with the performance of their system, and this gives you a really nice tool for being able to see what kind of workload is happening here, what are my fast queries, what are my slow queries, what do I need to work on optimizing. So if you want to know more about MongoDB 3.2, there's an excellent white paper you can download. The release notes are really good. There are a couple of other features that I didn't cover, and you can read more about it there. The Spark connector that I mentioned, there's a link for that. Also check out our blog, which has lots of good stuff. We just had MongoDB World week before last. And there were lots of cool announcements about some of the features that are coming up in new releases. So you want to check that out on our blog, and you can see what's coming in the next release, which will be 3.4, which will be coming out later this year. Questions?
What happens with schema discovery? Both, like, I guess the BI connector and Compass are probably both the same. That's not the point. What happens if a collection's not that consistency across all the documents?
Right, so both of them use, the question is, what happens if I don't have consistent schema? So I have, document A, which has schema A, document B, which has schema B.
90% have the same, but then 10%.
Yeah, so both tools use sampling. So hopefully you got some A's and some B's, and basically it would be the concatenation of all of the fields.
Oh, okay.
So in the SQL world, yeah, you just get yeah. Yeah, I mean, depending on the type of query, so you can do like a custom filter. So if you have like two different data types in the same collection, you could, in your mapping file, specify like this table maps to this data set, and you can actually add a custom filter there, and that would be one table. And then that same collection you could map again to a different table name and apply a different custom filter. And it would be presented to the database as if it were two different tables, but in Mongo, it's only one collection. Yeah, it's really simple.
How serious should I be about upgrading Mongo 3.0 and that to 3.2 wireless?
You should test it. I mean, it really depends on your application. I mean, it's probably, you're going to get a big win in terms of performance. The biggest thing is making sure that you get your drivers up to date.
Scheduled. There's only one more speaker.
Driver, make sure you test
Starts at 5:50, 30 minutes. And
completely different beasts, right? So an application that's optimized for
long days is the thing. That's the problem. So.
will hopefully be faster than
Are you good though?
MMAP.
You need
There could be some edge cases there where your performance profile should be. What you can do is, because you can have a replica set, have different storage engines, you can upgrade like one of your secondaries to white tiger and leave your other two secondaries with MMAP, and you can just let it run like that for a week. And there's, depending on how you have your read preference set, you might not be getting any queries, but at least it's already converted and ready. And then what you can do is flip it over. So do like a step down to your current MMAP primary and promote that wire tagger guy up to primary. So just let it run, monitor it very closely. If you happen to notice any kinds of issues with performance, then you could basically flip it back.
You guys have any issue running the sets?
So you're going from 3.0, well, you're on 3.0 MMAP right now. So I guess there's two things that you could do. One is you could stay on 3.0 and just put wire tiger into the mix. That would probably be the least number of changes if you just want to get to wire tiger. Or you could upgrade to 3.2, stay on MMAP. Go through all your testing there, and then I would try to do it in 2 steps. I tend to be pretty conservative. Depends, what kind of application it is. If it's a mission critical application, you might go slow and easy, and not do multiple changes at once. So you can go back and be able to isolate it.
Thanks, man.
Thanks.
I'll give this one a friend of mine. In the other room. And I told him this is the last one. Just keep the memory card handy. And log it up here, and I think we got stuff on the data. We'll give everything to Ozzy.
Oh, the sign-up sheet, anybody have that?
Okay, we're gonna meet right? Yeah, we'll meet here. Yeah, we'll meet here.
I'm fine.
Anybody?